Hey guys, in this video we're going to explore some special right triangles. Specifically today I'm going to show you an exploring exercise to kind of derive a shortcut that we have for finding missing sides in right triangles. So we're just going to follow these directions here. We're going to draw a diagonal in our square down here. So I'm going to draw the diagonal from D to B. I'm using a straight edge to kind of make it look a little bit nicer. Okay, so I have my diagonal here, and they're wanting me to measure a couple different things. They also want me to fill in the angle measures. Here, well, since this was a square, I know that all four angles are 90 degrees, but I did just cut those 90 degrees in half with that diagonal, so half of 90 is 45. So all of these smaller ones here are 45 degrees. Okay, so that's kind of the step two. So we knew it's a square. The diagonal is cutting that square in half, so it is cutting the angles in half as well. Now I'm going to use this ruler to measure the sides here. So they're asking me to measure AB, so that's the small one. I'm going to use centimeters here. All right, so I've got about 7.2-ish. Which, if this is a square, that means all of the sides would be the same. So that means AD would also be 7.2. The other one they're asking me to measure is the hypotenuse here. So using centimeters again, I get about 10.1, it looks like. Yeah, so we'll do 10.1, and again, these are in centimeters. Okay, so we want to come up with a shortcut that relates the sides to the hypotenuse. So is there some magic relationship here that is going on? So zoom in just a hair more here. Okay, so we're going to come up with an algebraic proof that's the relationship between the legs of the triangle and the hypotenuse. And we're going to use the Pythagorean theorem. So this first part says let AB equal x. Okay, so if AB is x, that means that all these other sides are x as well. So if I'm working with just this right triangle here, I'm going to use AD. So I'm going to say, then AD also is x. And our reason is because that's a square, right? So by the definition of square. So remember when we're writing a proof, anytime we say something, we have to have a reason for it. So we're saying, okay, AD is also x. That's because it's a square. The other piece here is we want to know what this side is. So our hint is use the Pythagorean theorem. So if these two legs are x, that's like my A and my B, and then my hypotenuse would be C. So by the Pythagorean theorem, if I plug those in, x squared plus x squared, my A and my B, has to equal C squared. And that is by the Pythagorean theorem. Okay, so we want to come up with a relationship between the hypotenuse and the side. So I'm going to solve this for C. But first I can simplify this a little bit. I have 2x squared over there. So what I'm going to do now to get what C equals is I'm going to take the square root of both sides. So over here what happens is the square root of 2, I'm just going to leave that as root 2. But then the square root of x squared is just x. And the square root of c squared is just c. So here is essentially my relationship, that if I have a side, x, and I multiply it by the square root of 2, that will give me the hypotenuse, c. Well, let's see if that worked out with my measurements up above. So if I take 7.1, my side, 7.2, and multiply by the square root of 2, so I'm taking the side length and multiplying the square root of 2, that should give me the hypotenuse, which pretty dang close. And keep in mind, we did a little bit of estimating and rounding, and it's taking root 2 and turning it to a decimal. So pretty dang close. So we can take a side length of a right triangle as long as it looks like this, and it should be multiplied by the square root of 2 to get the hypotenuse. So what kind of triangle was this exactly? Well, it was a 45, 45, 90. So we have a shortcut for any 45, 45, 90 right triangle. So you'll notice that I also have these congruent markings. That's because every 45, 45, 90 triangle is also isosceles. We saw that with a square, right? I basically cut a square in half. The square sides are the same length. So no matter what these are, so I'm just going to use x, they could be any number. The hypotenuse is that number times the square root of 2. So our rule is the legs are equal to x, and the hypotenuse is x times the square root of 2. Okay, so we're going to use that shortcut to find some missing sides here. So in example number 1, I know, because this is a 45, 45, 90, that the two legs are the same. So I'm going to put some variables in here. I'm going to call this x, I'll call this x, this x, and this y. So x, remember the legs are always equal because this was half of a square. So if this leg is x, so is this leg. So x has to be 8. Now the hypotenuse, remember, we get by taking whatever the legs are and multiplying by the square root of 2. So y is 8 times the square root of 2. Which, remember from leaving it in simplified radical form, that is in simplified form. So those are my two solutions for those two sides. All right, this next one is kind of the opposite. They give me the hypotenuse and are asking me to find the two sides. So I'm going to use x and y again. Okay, so remember how we get this hypotenuse in a 45, 45, 90 triangle. I know this is 45, 45, 90 because it's isosceles, and it's right. So if these are isosceles, these angles have to be the same. So I can assume it is one of those triangles, which means our shortcut is fair game. So the shortcut is that I take the leg, I multiply it by the square root of 2, and it equals the hypotenuse. So for this particular triangle, that's what's happening. The leg times the square root of 2 has to equal the length of 3 at the hypotenuse. So I want to know what x is. I'm going to get x by itself. So I'm left with x equals 3 over the square root of 2. Now, this answer is not in simplified radical form, right? I can't have a radical in my denominator, so I'm going to rationalize. So multiply straight across here. So I have 3 root 2, and then root 2 times root 2 is just 2. Quick check, I can't reduce that. 2 is not a radical I can break down any further. So this is what x is equal to. So x is 3 root 2 over 2. And remember, the two legs are always congruent, so that means y is also 3 root 2 over 2. So kind of the two methods we see is given a 45, 45, 90 triangle, if we have the leg, like we did in example 1, we multiply by the square root of 2 to get the hypotenuse. Or in example 2, we're given the hypotenuse, so we divided by the square root of 2 to get the leg, so doing the opposite. So this shortcut, you guys, applies to any 45, 45, 90 triangle.